Hello, good morning everyone. Today I would like to share with you about the average power and the RMS value. So before I talk about this, let's consider this linear circuit. Okay, so let's us consider this transmission of the energy from the source to a load through a given surface. Okay, as in this figure. So in the network of this figure, the voltage waveform Vt, okay, is given by the source, and the current waveform is determined by the response of the rod. So the source output independent is significant, then the Vt and the It both depends on the characteristic of the source and the rod. So if Vt and It are periodic, then they may be expressed as a figure series like this one. It equal to I naught plus summation of m equal to 1 to infinity Im cos m omega naught t minus this phase m. And for the Vt equal to V naught plus the summation from n equal to 1 to infinity Vn cos n omega naught t minus phase n. Okay, so in general, the instantaneous power, okay, is the Pt equal to VTIT. So it means that it's a P equal to VI. So, and the average power is the P equal to 1 over T naught because of the average. So 1 over T naught. The integration from 0 to T naught VTIT. So if you substitute the value of this V and I, like this one, the value of R and the value of V into this, the integration. So you will end up like this formula. Okay, the average power after you substitute the value of I and the value of V, so you will get this formula. So this is the formula for the average power absorbed by a circuit due to the periodic excitation. Okay. The RMS value of the periodic waveform xt, okay, with the period of t can be defined as x RMS equal to square root of 1 over t naught integration from 0 to t naught x squared dt. Okay, and also the RMS value can also be expressed in the term of trigonometric form and also exponential form. So this is in the trigonometric form and this is in the exponential form. Next is the parseval theorems. So for if xt is equal to the it, the current through the resistor R, okay, then the power distributed in the resistor is P equal to Rx RMS square or equal to the Ri RMS square. Let's say, but if xt equal to Vt is the voltage across the resistor R, then the voltage distributed in the resistor will be the P equal to Vrms square over R. Okay, so but what is Parseval theorem? So Parseval theorem actually is that the average power in the periodic signal is the sum of the average power in its DC component. DC, remember the A naught, and the average power in its harmonics. Okay. And this is the Parseval theorem that the power is distributed by the 1 ohm resistance. So P 1 ohm resistance is equal to the A naught plus half of the summation from A1 equal to infinity AN square plus BN square. So this is the formula for this power distributed at the 1 ohm resistance. Now let's look at the example for a Parseval theorems. Okay, let's say this is the Vt, okay, 30 plus 20 cos 60 pi t plus 45 degree plus 10 cos 120 pi t minus 45 degree. And the It is a 6 plus 4 cos 60 pi t plus 10 degree and then minus 2 cos 120 pi t minus 60 degree. So you need to find the Vrms, Irms, and the average power. So just now I already told you that what is the formula for the VRMS, right? So the VRMS is the A naught square plus half of the AM plus BN square. So A naught in this case is what? 30, right? So for the VRMS, so you look for the VT. So A naught is 30. And then you follow the formula AN, okay? AN is what? What is AN? Yes, 20. Okay, AN is 20. And then plus BN is 10. Okay, so 20 square plus 10 square. And then square root, you get 33.912. Okay, so for the IRMS, okay, you have the A naught is 30. And then for the AN is 4 and minus 2. So you follow the formula again, you get the RMS equal to 6.782. And then the question also asks you to find the average power. So just now I already mentioned to you, average power is VDC IDC, and then plus half the half VN IN cos theta naught minus phase. Okay, so DC and AC, VDC and IDC. So it's 30 and 6. Okay, so 30 times 6 plus half. Okay, VNIN, as you know just now, is 20 and 4. Alright, 20 and 4. Cos theta n. Theta n is the degree, so 45 minus 10. 45 minus 10. Okay. And then plus with 10 times 10. Okay, another one, 10 times minus 2. Okay, and the degree is negative 45. And then minus 60, negative 60. So this is the second part. So when you solve it, you'll get 203.107 watt. Next, look at another example. The input to the RC filter is this one. Vs is equal to the half minus 1 over pi, and the summation 1 over n sine 2 pi nt. And then you need to determine the output, and this is the figure. Okay, this is the figure. You have the Vs, you have the resistor 2 ohm, and the Vout. Okay, and so in order to solve this question, you need to transfer the circuit into a frequency domain. Okay, just like the kind of engineering max, but it's not. But kind of you need to some basic of this one. So you have the resistor of 2 ohm, and C is the capacitor is 1 over j omega nc. Okay, 1 over j omega nc. Not that omega n is equal to n omega naught. So omega naught in this case, okay, you refer to the equation. Okay, sine 2 pi nt. So sine omega naught t. Okay, so omega naught t means that one omega is 2 pi. Okay, n omega naught t. So sine n omega naught t. So it's omega naught is 2 pi. So you know that omega n is n omega naught. So it's n 2 pi. Alright, so you substitute into the omega n. So you get 1 over 2 pi n. So this is the first step. And then you change the amplitude phase, change into an amplitude phase form. Okay, you change to an amplitude phase form. Vs equal to half. Okay, so means that this one you change to from the sine you change to a cos. Okay, how to change the sine from the cos? You change the phase. Okay, initially you have the sine, the waveform of sine. Then you change to a cos, so you need to plus 90, right? So therefore, Vs equal to half minus 1 over pi. Okay, this one remain. Cos, from the sine you change to the cos. Cos 2n pi t plus 90. So you change the phase. Okay, you change the phase. So what is the Vs, okay, in the Phasor form? So this is the Phasor form. So 1 over n pi, so this one, this is the DC. This part, 1 over n pi, and then the percentage, the degree is 90. So it's a 1 over n pi with the 90 degree. Okay, then what is the response function? The response function for the current I is Vs over impedance Z, or V0 over capacitor, VR over capacitor. So impedance is referred to the resistor and the capacitor. So resistor, as you know, is a 2 ohm, while the capacitor is 1 over 2 pi n. So you add together, then you get J 4 pi n plus 1 over J 2 pi n. Yeah. Next is the output. Okay, the output V out. V out is equal to the Vs divided by the source. Vs is the source divided by the impedance times with the C, because you need to find the V out at the C here. It's not at the resistor. So Vs over the total impedance times with the C here. And then you get Vs, okay, Vs over the Z. The Z is referred to the Z, this one that you find just now. Okay, time with the C is 1 over 2 pi n. So you cancel out the 2 pi n, you get Vs over 1 plus J 4 pi n. Okay, then what about in the Phasor form? Okay, Vn is equal to the Vn with the phase of phase n is an minus j bn. So what is the Vn? Vn is an squared plus Vn squared. Okay, from here you know that the an is 1, Bn is 4 pi n. Maybe you might ask where I get those 1 and 4 pi n. If you look at this one, okay, this V0 over 1 plus J 4 pi n. So actually is referred to the V out. If this is V out, right? So V out equal to the Vs over Vn with the phase n. So this is referred to the Vn phase n. Okay, I repeat again. So V out actually is referred to the V out equal to Vs over Vn phase n, this one. So this phase n and the Vn is from here. So therefore, An is 1, Bn is 4 pi n. Okay, that is you get here. So you solve this one, you get Vn is this one. And then the phase n is negative inverse tangent Bn over An. So Bn is 4 pi n, An is 1. So you got a negative inverse tangent 4 pi n. Okay, so what is the DC component? As I told you before, that the DC component is the when n equal to 0. So Vs, you get half, and V0, you get half as well. If you not believe, you go back to the question. Okay, half. Okay. And then you calculate for the AC component. So as you know just now, V out is equal to the Vs over Vn phase n. So same here, Vs. Okay, Vs is 1 over n pi with the phase 90. So it's from the front. Okay, from the front. And then the Vn is this part. So this is the Vn. This is the phase. Okay, so you write in this way. Okay, this is Vs, this is the Vn. Okay, so you just this is the amplitude and this is the phase. So phase is 90 degree minus inverse tangent 4 pi n. And then you add the DC and AC components together. So V out is equal to half is the DC plus the summation of this part and this part. So this is the Vn, this is the Vn. So this is two part lah, the summation of this one and this one, the phase and the amplitude plus with the DC component. So this is the V out. And then you also can change to an amplitude phase form. Okay, xt is equal to the a naught plus the an cos n omega naught t plus the phase n, right? So you can change it to the amplitude phase form. Alright, you can change it to the amplitude phase form. So that's all for this average power, RMS, and the Phasor theorem. Okay, thank you very much. Thanks for watching.